We've seen that under majority rule voting, as long as people's preferences are single-peaked over a single-dimensional set of alternatives, there's one alternative that'll defeat all other alternatives in a pairwise majority rule vote. But in order to get that result, we had to violate one of error's conditions, the condition of universal domain that says that people ought to be able to hold any rational preferences, not just single-peaked preferences. So when we relaxed the assumption of single-peaked preferences, we ran into another violation of one of the conditions of error's theorem, a violation of rationality. The social preference ordering was now no longer rational. It violated transitivity. Now we'll take a look at another voting system that's gained in popularity recently. It's called the instant runoff system. So imagine more than two candidates running for a single political office. We'll ask the voters to rank the candidates. So tell us who your first choice is, who your second choice is, who your third choice is, and so forth. Then we'll count the ballots in several rounds until we get a winner. In the first round, we'll count up all the first choice votes that each candidate got. If one of them got a majority, that person's the winner. But if no one got a majority, we'll eliminate the candidate who had the least first choice votes and go into round 2, count the ballots again, and see if now anyone wins a majority of first choice votes. If so, that person becomes the winner. If not, we eliminate the next candidate who got the least first choice votes and go into round 3 and so forth. So suppose, for example, we had 3 candidates, A, B, and C, and we have 5 voters, and the first 2 voters like A better than B better than C, the third voter likes B better than A better than C, and the fourth and fifth voters like C better than B better than A. So how would the instant runoff system work? Well, first we'd go into round 1. In round 1, we count up all the first choice votes. So candidate A gets 2 first choice votes, candidate B gets 1, and candidate C gets 2. So no one gets a majority, so we eliminate the candidate who got the least first choice votes, candidate B. We then go into round 2 and count the votes again, only now we no longer consider candidate B. We only consider A and C. So how many first choice votes does A now get? Well, he still gets these 2 votes, but the third candidate also likes A better than C. So that's a third vote for candidate A. Candidate C then gets these 2 votes. A gets a majority, so A wins the instant runoff election. Now imagine the following. Suppose that the fourth and fifth voters reverse their preferences over candidates C and B. So they reverse their preference ordering over these. So now they like B better than C, better than A, B better than C, better than A. Notice what we've done. We've reversed individual voter preferences over candidates B and C. But we haven't changed how they feel about A relative to B. So if we reverse how people feel over B and C, error's independence of irrelevant alternatives assumption, IIA it's sometimes called, says that that shouldn't change how the society feels over A and B. We've just changed how they feel over B and C. We haven't changed how they feel over A and B. So let's see if that still holds. So we run the election again. Round 1. We see how many first choice votes. So candidate A gets these 2 votes. And candidate B gets this vote, and this vote. So candidate B gets 3 votes. We already have a majority rule winner. We don't have to go into round 2. B wins. So by changing how 2 of the voters felt over B and C, we've changed the outcome of the instant runoff election. A won before, B wins now. We've changed the social preference ordering over A and B by changing how two voters feel over B and C. That's a violation of independence of irrelevant alternatives. We've changed how two voters felt about two irrelevant alternatives when we consider A versus B, and yet that changed how the social preference ordering emerging from the instant runoff ranks A and B.